Okay, so in this video here, we're being asked to find the distance between the points of intersection. And you can see here that I'm dealing with a line and I'm also dealing with a circle. So this equation right here is going to be a line. This equation right here is going to be a circle. So think about what they're actually asking for here. So what I'm going to do is draw the circle and I'm going to draw the line and I'm going to show the line intersecting through the circle. So for example, if I draw my circle, doesn't have to be perfect, right? And then I have my line intersecting through it. It's going to be passing through at two different points. Now, we're assuming that the line is not going to be tangent, okay? But we're going to be able to prove that out anyways when we do the problem. So assuming the line's not going to be tangent to the circle and it's actually going to pass through two different points, I'll have a point here and I'll have a point here. So essentially what they want is this distance right here, okay? And we'll call that distance D. So how do we get that? How do we get that distance? Well, the first thing that you need to do is you need to get both of these points. So go back to system of equations. When you solve a system of equations, you are essentially solving for the point of intersection. Now, on this particular example here, since I'm dealing with a line and a circle, I'm going to have 2 points of intersection and I'll have 2 different solutions here. So I'm going to solve it just like I would a system of equations, and it's up to you how you want to solve it. You can use substitution, you can use elimination. It's not going to matter. For me, I'm going to use substitution because I can see that on my first equation right here, so equation 1, my y variable is already solved. And I can simply plug that y variable into equation 2 right here, wherever I see a y. So for example, right here. And that's what I'm going to do. Once I do that, I'll get it in terms of x, and then I can solve for the remaining variables. So for example, I'm going to write here x squared plus, and now here's my y, I'm going to plug in 2x plus 5. Then I'm going to square it, equal to 50. So a common mistake, you are not taking this exponent of 2 and you are not applying it to both of your terms. So for example, you are not doing this. You are not saying, okay, 2x squared is going to be 4x squared, and 5 squared is going to be 25. This is going to be incorrect if you do it this way. We have to do FOIL. You have to do first, outside, inside, last. It's a binomial. You're squaring it. So again, you have to expand it out using FOIL. So for example, what we're going to do here, we're going to rewrite 2x plus 5 2 times, and we're going to multiply it out. Okay? So I'm going to go ahead and rewrite the problem. I get x squared, and then doing FOIL here, first I get plus 4x squared. When you do outside and inside, you get 10x. That means I'll have 10x plus 10x, that will give me 20x. So plus 20x. And then 5 times 5, that's going to be last, I get 25, plus 25. All equal to 50. Okay? So from here you can see that I have a quadratic. How do we solve quadratics? Well, we set them equal to 0 and then we try to factor. If we can't factor, we'll use the quadratic formula. So I can combine like terms here and here. That will give me 5x squared. Then I have plus 20x. And then I have to subtract 50. That will give me 25 minus 50. I get negative 25. Okay, all equal to 0. So from here, can you factor it? And before you try to factor, you always want to try to pull out a greatest common factor because it could make the problem easier. And I can pull out a greatest common factor here. I can pull out 5. Okay, so for example, I'm going to scroll down. That way I have room to continue on with the problem. Right? I'm going to pull out a 5. So pulling out a 5, that leaves me with x squared plus 4x and then minus 5 equal to 0. So this 5 that I pulled out, I don't really care about. That's coming along for the ride. I am worried though about this quadratic right here. I want to try to factor it. So how do you factor? Well, I use the AC method. That's the way I teach. So I'm going to do a times c. That will give me negative 5. And if you don't know how to do the AC method for factoring, I have videos on that. So go ahead and check the link below. I will link both of those videos on factoring, both when a is equal to 1 and a is not equal to 1. But assuming you know how to factor, I'm just going to go ahead and run through this pretty quick. I get a times c, I get negative 5. Two numbers when I multiply will give me negative 5, but add up to 4, my b value right here. Okay, well that's going to be 5 and negative 1. When I multiply, I get negative 5. When I add, I get positive 4. Now, since a is equal to 1, I can put it right in factored form. So I get 5, and then times x plus 5, then x minus 1, all equal to 0. From here, you have to go ahead and solve each one of your factors. Now, this is a factor right here. So when I set it equal to 0, can I solve? Well, 5 equal to 0 doesn't help me. There's nothing to solve for. So this factor is actually irrelevant. We don't need it. Okay? But this factor here, x plus 5, when I set it equal to 0 and solve, I get x is equal to negative 5. And when I solve this factor here, I set it equal to 0, I get x is equal to 1. So what you just found is the x value of these 2 points of intersection that this line is passing through on that circle. We now have to get the y value. So how do we get the y value? Well, you go back to the 2 original equations. So I'm going to scroll up here, and you plug it back in. Now, it doesn't matter which equation you plug it back into. So my recommendation to you, plug it back into the easier of the 2. Okay? So again, if you plug it into equation 1 or equation 2, you're going to get the same y value regardless. So again, pick the easier of the 2. And so that being said, I'm going to pick equation 1, right? That's way easier. So I'm going to go ahead and scroll down, right? I'm going to write down that equation. It is y equal to 2x plus 5. And then from here, I'm going to go ahead and plug in my x values that I found. That way I can get the y values, okay? And that will give me the 2 points. So taking negative 5 and plugging it in, we get y is equal to 2 times the negative 5 plus 5. So y is equal to negative 10 plus 5, or in other words, y is equal to negative 5. That is going to be a point. I plugged in a negative 5 and I returned a negative 5 for my y. So 1 point here is negative 5, comma, negative 5. There's 1 point of intersection. Why don't we go ahead and box that in? Okay, that's not our final answer, but again, we're just going to go ahead and box it in. That way we know where it's at. Now I'm going to plug in 1. I'm going to plug in this value right here to get the y value. So I'm going to say here, y is equal to 2 times 1 plus 5. So y is equal to 2 plus 5, or y is equal to 7. So again, we plugged in a 1 and we returned a 7. So I'm going to say here as a point, it's going to be 1, comma 7. Okay, and that's done. Now from here, you're not done, but you did the hardest part. Now we have the points of intersection. All we have to do now is get the distance between them. So again, if you look at the picture that I drew up here again, we're looking for that distance d. We now have both of these points right here and right here. And again, my picture is not exact. It may look a little bit different, but you have the idea, right? That line is passing through that circle at 2 points. So from here, we have to use a formula. And that formula is going to be the distance formula. With the distance formula, we're able to get the distance between 2 points. So why don't I go ahead and write that formula down here, again, scrolling down, and we're going to kind of cram it in here. But we get distance is equal to the square root of, and then you're going to have x2 minus x1 squared, and then you'll have plus y2 minus y1. And then squared, okay? And so that's what we have to plug in. So what's my x1, what's my x2, what's my y1, what's my y2? Well, that's gonna be the points that you found. So for example, I'm just gonna take this first point here, negative 5, comma negative 5, and I'm gonna call it x1 and y1. Now you could call it x2 and y2, that's fine, but just make sure you're keeping the 1s and 2s together. So for example, if I call this x1, this cannot be y2. Okay, you cannot do that. You have to keep the 1s and the 2s together. So as long as you keep the 1s and the 2s together, you're fine. It doesn't matter which one you call which, all right? So I'll call negative 5, comma negative 5, x1 and y1. And then this point right here will have to be x2 and y2, okay? And now all I have to do is plug it in. So I'm going to say here, distance is equal to the square root of, okay, and then we're going to have, in parentheses, x2, that is going to be 1. So I have 1 minus a negative 5. Those two negatives make a positive. So I get plus 5, and then I square it. And then I get plus y2, that's going to be 7. So 7. And then same thing here, my y1 is negative. and I have a minus in my formula, so a negative and a negative, that will make a positive. This y1 goes in as positive 5, so plus 5, and I'm going to close it and then square it. Okay, so from here, you just have to plug it into your calculator and solve. And so when you plug this in, you end up getting distance is equal to the square root of 180. Okay, that is going to be your final answer. We're going to go ahead and box that in. Okay, now that is an irrational number. 180 is not a perfect square. So you could round it if you want. You could take the square root of 180 in your calculator and then round it. But leaving it in terms of the square root of 180 degrees is going to give you the most accurate answer because, again, you're not going to lose any accuracy when you round. I have the entirety of that irrational number by leaving it as the square root of 180. So again, my recommendation to you, whenever you have a square root that is not a perfect square, just leave it like that. Don't bother rounding it because then you're going to lose accuracy. All right? And that's done. So if the video helped you or if you gained anything from the video, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.